Functional groups are groups of atoms within a molecule that have a characteristic chemical behavior, meaning different reactions can take place. We will go through each functional group and the important characteristics to look for. We will start with alkanes that have all single bonds, and from there, molecules become more complex as different groups are added. Alkanes will have all single bonds between carbon atoms CC and CH, and we look for no double or triple bonds, just simple chains or branch structures. Alkenes contain at least one carbon-carbon double bond. They can have multiple double bonds like dienes or trienes, and will still contain single bonds connecting the other carbons as well as CH groups. Alkynes contain at least one carbon-carbon triple bond. They can have multiple triple bonds like dienes or trienes, and will still contain single bonds connecting the other carbons as well as CH groups. For aromatic compounds, also known as arenes, look for a benzene ring. A benzene ring will contain 6 carbons in a ring with alternating double bonds for a total of 3 double bonds in the ring. Alcohols will contain an OH group bonded to a carbon, and it can be anywhere in the structure. Thiols contain an SH group bonded to a carbon. Similar to alcohols, but with sulfur instead of oxygen, sulfur and oxygen will have many analog functional groups because they are both chalcogens in group 16 of the periodic table, meaning thiols are the sulfur analogs of alcohols, thioethers are the analogs of ethers, and thioesters are the analogs of esters, among others. Ethers will have oxygen atom bonded in between 2 carbons. For sulfides, also known as thioethers, they contain a sulfur atom bonded in between 2 carbons. The sulfur here plays a role similar to oxygen in ethers. Disulfides contain a bond between 2 sulfur atoms. Amines will have nitrogen bonded to 1 or more carbons and will always have 3 bonds. If the nitrogen does not have 3 bonds, add hydrogens to create those 3 bonds needed for a formal charge of 0. Aldehydes will have a carbonyl group, and this is a C double bonded O at the end of a chain bonded to at least 1 hydrogen. Ketones will contain a carbonyl group in the middle of a chain in between carbons. Carboxylic acids contain a COOH group, and that's a carbonyl attached to an OH. Esters contain a carbonyl group bonded to an oxygen that is then bonded to another carbon. Amides contain a carbonyl group bonded directly to a nitrogen, and the nitrogen will have 3 bonds coming from carbons or hydrogens. Alkyl halides contain a carbon bonded to a halogen atom, Cl, Br, I, or F, and nitriles contain a carbon triple bonded to a nitrogen. Each of these functional groups has a specific signature that makes it identifiable. Look for bonds beyond single bonds as big clues. These can be double bonded carbons, triple bonded carbons, or the COO group for carbonyls. Watch for heteroatoms. These are oxygen, nitrogen, or halogens because they nearly always mark functional groups. Pay attention to whether a group is at the end of a chain, like aldehydes or carboxylic acids, or in the middle, like ketones. Once you learn to quickly recognize these patterns, identifying functional groups becomes almost automatic, and it will help you predict how each molecule will behave in chemical reactions.